Hi guys, this is my third video about the symmetry properties of the unit circle. So I've already done a video on finding the table of exact values or deriving it from the two triangles. And look, by now you should be pretty familiar with the table of exact values. So we're going to use that in order to answer these questions here. So this is worked example 3 from your JAC Plus textbook. So look, I'll start with the cos of 2 pi on 3. So I'm going to draw a picture, and with circular functions you really want to draw lots of pictures because it's really easy to see how the triangles move around the circle when you can view it on the unit circle. So let's see, cos of pi on 3 is within the table of exact values. So if I was going to draw the cos of pi on 3, it would be referring to this, and with an angle of that. So that would be our basic angle, and our basic angle always is in quadrant 1. So what we want to do is now move that triangle around so that it can go to 2 pi on 3. So we always start measuring from 0, and well, what I like to do is label the triangle with the angles, so 0, and then this is pi, but because we're looking at pi on 3, I'm going to call that 3 pi on 3. So you don't have to, but it's quite convenient to work with the fractions with the same denominator. And then, of course, if I go all the way around the circle, I'm going to get to 2 pi. And 2 pi would be 6 pi on 3. So I'm going to write 6 pi on 3. So 0, 3 pi on 3, and to 6 pi on 3 all the way around the circle. We'll get rid of that. So now if we're looking for 2 pi on 3, we need to consider where that's going to go. So if half the circle is pi, well then if you're looking for 2/3 of that, well there would be 1/3, 2/3. So you can see that 2/3 would take us to somewhere here. And the actual angle of 2 pi on 3 would be this here. So from the 0 up to here. So that would be our angle of 2 pi on 3. What we now need to do is make the triangle again as part of the butterfly. So essentially we're picking up this triangle and moving it over to quadrant 2. So I'm just going to really flip it across, and therefore it would look like this. And well, this would be our cos value along here, and our sine value would be the height of the triangle there. So we're looking for the cos of 2 pi on 3. So we're looking for the yellow length there. And we know from the table of exact values, if we go to cos of pi on 3, we can see that equals a half. So that means that this length here is half. Well, now that we've put our triangle over to this side, well, that means that the x value, or the length here, is still half, but it's going to be negative because it's in quadrant 2, and quadrant 2 corresponds to a point somewhere here on the Cartesian plane where your x value would be negative. So our answer to cos of 2 pi on 3, we can say it's negative half. So the important points there are: step 1, choose the basic angle, which you would find in the table of exact values. So if it's pi on 6 or pi on 4 or pi on 3, choose which one that's going to be. Step 2 would be to move that triangle into the appropriate place. So in this case we did now, it would be quadrant 2. Step 3 would be then to, well, decide the size of the angle and also the size of the length, or the length of the line, the cos or sine, or tan for that matter, and then decide whether it's positive or negative. So look, let's go for the next one, and I'll do it on the same unit circle, I think. So now we're looking at the tan of 7 pi on 4. So this time when I label the unit circle, I'm going to change my pi and 2 pi. So I'm going to put the same denominator again. So we've still got 0 here, but this time we're looking at a denominator of 4. So we're looking for 7 pi on 4. So I'm going to say 0, I'm going to say 4 pi on 4, and I'm going to say 8 pi on 4. So now if I go around the circle and I want to get to 7 pi on 4, 8 pi on 4 would be here. So 7 pi on 4 would be a little bit less than that. So our angle would exist in the fourth quadrant. And here's quadrant 3. So now I'm going to make the triangle part of the butterfly. My original angle, well, would have been here. And we're saying it's got a denominator of 4. So we're looking at this, and we're looking for the tan of pi on 4. So the tan of pi on 4, now we can say, well, tan in the fourth quadrant, tan is sine over cos. And our sine value in quadrant 4, well, that's negative. That would be a negative y value. So it's a negative divided by the cos value, which in this quadrant, this would be a positive cos value. So it's negative divided by positive. So that means our tan value would be overall negative. So we can see that tan is negative in this quadrant. And now we can also see that the tan of pi on 4 is 1. So, well, now because we're in the fourth quadrant, that's going to be negative 1. So the tan of 7 pi on 4 is negative 1. All right, 2 more to go. So now we've got cos of negative pi on 6. And actually, this is going to stay the same for the triangles, as you'll see in a minute. So let's put our angle of pi on 6 into our normal basic angle triangle. So in quadrant 1, so pi on 6. And remembering from, I think the first or second video I did on symmetry properties, when we make a negative angle, we're going in the negative direction of the unit circle. So now we're going to put the pi on 6 in here. And now we can say, well, we're looking for a cos value. The cos value is the x value of that. And you can see that it's still positive. So actually it's exactly the same spot as if it was in the first quadrant. So it's going to be positive. And the cos of pi on 6, let's see where that is. Oh, this won't rub out. There we go. Cos of pi on 6. And we can see that's root 3 on 2. So we're going to be positive root 3 on 2. So you don't need to write the positive there, but just so you can see that I've considered whether it's positive or negative, I'm going to leave it there. Let's now look at the last one, which is looking at the sine of 11 pi on 3. And sometimes it's a little bit annoying when they've got large numbers there, but really it's not too bad if you think of your common denominators. So, for example, in this one, our common denominator of 3 would mean that we have 3 pi on 3 over here and 6 pi on 3 here. So if we're going around the circle, we can say 3 pi on 3, 6 pi on 3, 9 pi on 3. If we go one more, we get to 12 pi on 3. So we're going to be minusing pi on 3. So it's going to take us back by pi on 3, and it's going to mean that our angle is now down here. And of course, every time we draw our angle, it's going to be part of the butterfly. And of course, my circle is not really very much like a circle there, but you can see what I mean. So this is going to be a pi on 3 in here. Considering the basic angle in quadrant 1, there's pi on 3, and we're looking for a sine value. The sine value in quadrant 1 is positive, as is the tan and cos. But in quadrant 4, where we've got the sine of 11 pi on 3, you can see that it is negative. So this value here would be negative for y. So sine is negative here. So we can say it's going to be negative. And then we can look on the table of exact values, and we can go the sine of pi on 3. So sine pi on 3, and it's going to give us root 3 on 2. So now it's negative root 3 on 2 for this one. So when you do these, always think about the basic angle, and you can find what your length of any sine, cos or tan is from your table of exact values. You then just have to move your triangle into the correct quadrant and decide whether you're going to be negative or positive.